Hey 8th graders, today's lesson is 1.6 force and motion, and your learning targets for today, I can model how different strength forces can cause different changes in velocity. So first and foremost, this is the last lesson in chapter 1 where we're kind of learning about how we can use different forces, different strength, different direction to cause those 5 different changes in motions, or basically cause unbalanced forces that cause an object to move. And then we're also looking at how those objects might move. So really we're getting into those fine-tuned details in this lesson before we move on to adding mass into the equation. With that being said, I talked to you guys about this with 1.5 is that you guys need to learn how to do these modeling tools. As in this lesson today, your 2 modeling tools that you guys submit will be counted as a quiz grade. Okay, so again, those kind of mark a little bit more into our Power School and into our overall grade than other assignments do. So keep that in mind as you guys go through this, that you guys are completing this assignment like you guys would a test or a quiz. Okay, moving on though, let's go ahead and take a look at our warm-up. So normally when the thrusters fire, the pod will stop, but the mission was different. So we're going to revisit that space pod, that little asteroid collection mission that we've been talking about throughout this whole first chapter. So again, we have our little space pod come in, it's moving toward the right. Our thrusters fire and exert a force in the opposite direction, which causes our little space pod to stop. And then when it stops, it's able to dock with the space station. So that's how a normal mission fires. So I want you guys to keep that in mind. Again, it's moving in at a medium speed. The thrusters fire at a medium force in the opposite direction. That causes our pod to stop, allows it to dock with the space station, and then it can drop off its asteroid collection samples. So every other time these asteroid collection missions have run, that's the typical scenario as to what you guys see when that those little pods come in. However, in the instance of the occasion that happened in the video earlier in this chapter, we kind of had those seconds that the video feed cut out and we didn't really know what happened. All we know was when the video finally did come on, that space pod was moving away in the opposite direction. So from that, we were able to come up with 2 claims. Okay, claim number 1 says that the thrusters cause the pod to move in the opposite direction. So what you guys really need to think about is, how would the thrusters cause that pod to move in the opposite direction? So what would the force from those thrusters look like to cause that pod just to stop, turn around, change direction, and move backwards? Okay, so here's kind of the typical, this is the pink one. The pod approaches the space station at medium speed. The thrusters fire to stop the pod, but in the case of claim 1, the thrusters cause the pod to turn around and move in the opposite direction. So if we're talking about those 5 changes of motion, change direction is what we see with this. So what you really need to think about is what kind of force is going to cause that pod to turn around and change direction and go away from the space station. Okay, on the other hand, we have claim number 2, which is right here. The thrusters only slowed the pod, it didn't stop. The pod hit the space station, which made it bounce off and move in the opposite direction. So again, same thing, the pod is approaching the space station at a medium speed. The thrusters are going to fire to stop the pod, but the pod hits the space station instead of stopping, and it bounces off and moves the other direction. Okay? So again, you guys need to think about what kind of force would the thrusters had to have exerted on that pod to only slow it down, not stop it. Therefore, it stayed moving, it hit the space station and bounced off and moved the opposite direction. Okay, so really focus in on the force that those thrusters would have caused to have our space or our pod either just turn around and move in the same direction, or to keep going, hit the pod and turn around. Okay, so really think about that as you guys move throughout this unit. All right, moving on though to your guys' warm-up question is knowing a little bit more about claim in 1 and 2. Let's take a look at claim 1. If the pod went in the opposite direction because of the thrusters would have exerted blank the usual thruster force from other missions. So you guys will use your draw tool to circle either a greater force than, a force less than, or a force equal to the usual thruster force from other missions. Okay, so which phrase there fills in that blank? Okay. Claim number 2, if the pod crashed into the space station because of the thrusters would have exerted a force greater than, a force less than, or a force equal to the usual thruster force from other missions. So this is where you guys really identify what happens with that force from either claim 1 or claim 2 to cause those two hypotheses to happen. Okay, again, either turning around and moving the opposite direction, or not slowing down enough, hitting the space station and bouncing off and going the opposite direction. Okay. All right. With that being said, okay, once you guys are done answering the question, let's talk about those. Okay. In claim 1, if the pod went in the opposite direction because of the thrusters would have exerted blank, so either a greater, a less than, or a force equal to the usual thruster force. So again, if our object is moving in a medium speed and we want it to stop, think about which direction our force would need to be and how big it would need to be. Okay. If this pod just stopped and turned around and moved in the other direction without even coming in contact with the space station, that force should have been greater than normal. Okay, so every other collection mission, okay, the force is enough to stop it, but in this collection mission, it just straight up turned it around and changed its direction. So a force in the opposite direction that's greater than would have been the answer for that one there. Okay, for claim 2, we only slowed the pod down. Okay, with that being said, compared to our regular missions, the force would have been less than, and that would have been enough to slow it down, but not enough to stop it and allow it to dock. That would have caused this, the pod to hit the space station and bounce off. So just to kind of double check, those are your two answers for claim 1 and claim 2. So if you guys didn't have those, let's go back and fix them. And then let's go ahead and move on to the assessment part of today's assignment. So this is activity 2 modeling. And again, remember, I'll be grading these 2 modeling tools that you guys do as an assessment or a test grade. Okay, so this is the same little image that I showed you guys earlier. Again, normally when the thrusters fire, the pod will stop, but this mission was different, okay? So normally the pod comes in at a medium speed. It's moving to the right at a medium speed. The thrusters fire, and that force stops the pod. The pod can then dock with the space station and unload its samples, but that didn't happen. Again, claim 1, the thrusters caused the pods to move in the opposite direction. Or claim 2, the thrusters only slowed the pod, it didn't stop it, and that allowed the pod to hit the space station, which caused it to bounce off and move in the opposite direction. So those are the 2 claims you guys are going to be modeling in these 2 modeling tools. So let's move on to the next slide. Slide 6 is all about claim 1. Okay, so for this one, you guys will need to first right-click and open the modeling tool. It looks a little bit something like this, and I just want to explain some key points to this before I let you guys go ahead and do this modeling. Okay, notice that this first row you guys see here is most ACM pods. So what you guys are going to do is you guys are going to model, take a look at what happens with most ACM pods. So notice that we have the medium speed out there. So the pod moves in with a medium speed. The thrusters fire, so that's our during force. This pink arrow shows us the force of the thrusters. Notice it's moving in the opposite direction. Okay, anytime we want to stop an object, we have to apply a force in the opposite direction of its motion. So if it's moving into the right, the force has to be applied to the left. Okay, so because it's a medium speed and we want to stop it, we would use a medium strength force. Okay, that would allow our pod to stop. So this first row here shows you guys what every mission should look like for these little ACMs. But in the case of our ACM that we're studying in this unit, okay, that didn't happen. Remember that claim 1 states that the pod just turned around and moved in a different direction. So let's take a look at our instructions up here. Model the thruster force that would have caused the pod to move in the upper direction. So here are the 2 things you need to accomplish to finish this model. Okay, you need to first add an object here and an object here. Okay, this is our during the force column, so you guys need to also add an arrow here. So model what size and what direction force you guys think would happen for claim 1 to cause that pod to just straight up turn around and move in the opposite direction. Okay, and that's going to be your during force. You guys can kind of compare what happens in a normal mission and think, how is this mission different? Okay, you guys need to choose the correct size of arrow, and you need to choose the correct direction of your arrow. Okay, then you guys need to model what the velocity or the motion of the pod looked like after this happened. So this shows us what happens with the thrusters. Once the thrusters fire and apply that force, what does the velocity look like? So again, you guys will need to click and drag your objects, okay? And then you guys will need to use the arrows, okay, whichever one is appropriate to show the thruster force, okay, when this pod mission went wrong. And then you guys need to use the different speeds to show what the velocity would look like and in the correct direction of the movement of the pod after the thrusters fire. So think about what happened after the thrusters fired for claim 1. Okay, when you guys are done with that, you will screenshot. Again, if you're using a Chromebook, Control Shift and then the little key above the number 6. You guys just need to screenshot this little area right here that shows before, during, and after. This is just your little key for things. So I am concerned with grading this part right here. I do not need your whole screen. Okay, so once you guys are done with that, go ahead and screenshot your modeling tool for claim 1 right here. Again, claim 1 is that the pod just turned around and moved in the opposite direction. You guys should be showing me the correct thruster strength and thruster direction for that force and the correct velocity and direction of velocity for the after pod movement. Okay, very similar to that, you guys have the modeling tool for claim 2. So remember, again, that claim 2 states that the pod only slowed down, it didn't stop, and it kept moving. So again, notice this first row here shows you guys what happens in a normal mission, okay? The pod moves in a medium speed, the thrusters fire in a medium force in the opposite direction. That stops the pod, which allows it to dock with the space station. But in claim 2, we had a different hypothesis about what happened. Remember that this one, you're gonna model the thruster force that would only slow the pod, not stop it, and cause it to hit the space station. So we're not talking about a collision yet. So I just want you guys to show the force from the thrusters on the space pod and the movement right after the thrusters fire. So what is that pod doing after? So just like in claim 1, you guys need to click and drag your 2 little objects out there. In this middle box, you need to show me the force. So again, the correct direction of the force and the correct size of the force. Use those pink arrows. Okay, it doesn't matter which side you guys put them on as long as they point in the right direction. And then finally, you guys will model what the velocity of that pod looks like after. Again, correct direction, correct size. For the velocity though, remember that the little speed thingy should only go after. So if it's this direction, it'll go this way. If it's this direction, it'll go that way. So it'll go after it. Okay, so that side of the thing does kind of matter. You guys wouldn't put it in front of its motion. Okay, anyway, go ahead and model that, and then same thing, you guys are gonna model that, screenshot it, just this little section here, and you guys are going to put that in on to slide 9, okay? Remember that this is a test grade, so you absolutely have to do these 2. If you guys don't turn either of those in, I can't really give you guys a grade for that test. Okay, so make sure you guys do a good job with those. And then finally, once you guys are done with that, you guys can move on to this last activity. So this is a little cause and effect writing. So if you guys have ever seen those little magnets that you put on your fridge that are word magnets, this is kind of the activity I set up for you guys today. So I have a bunch of different words related to this topic that kind of act as those little word magnets. And you guys are going to rearrange these word magnets to answer this question, okay, or complete the statement rather. Okay, claim 1. Firing the thrusters would have caused the pod to move in the opposite direction if, okay? You guys are going to go ahead and explain how in claim 1 firing the thrusters caused the pod to move in the opposite direction. You definitely want to include force and velocity somewhere in that description. So you guys will go ahead, grab words down here that you need, okay? If there's a word down there that you want to use but it's not there, find a substitution. Okay, so click and drag your guys' words however you need to. Maybe read through them first, and you guys will go ahead and put together an explanation based on these little word magnets. Okay, you guys will do the same thing for claim 2. So firing the thrusters only slowed the pod, it didn't stop. The pod hit the space station, which made it bounce and move in the opposite direction. This would happen if. So go ahead and finish that statement. Explain to me why claim 2 would have caused the space pod to only slow down, hit the pod, and then move in the opposite direction. So again, you guys should probably have some good words like vocab, exert, force, velocity, stuff like that. Okay? Once you guys have constructed your 2 explanations for claim 1 and 2 with those little refrigerator magnet words, You can go ahead and do your wrap up. Any questions, circle yes or no. If you have a question, you can type it there. If not, leave that blank. And then 4, 3, 2, 1, how do you think you did? Finally, you are all done. Go ahead and hand it in. I hope you guys are having a great day. Thanks. Bye.